With that, it's my pleasure to introduce our final speaker, Raoul Adamchak, the farm manager of the UC Davis Student Farm, who will be talking about how do you make organic farming mainstream and make this intersection possible.
First of all, thank you for inviting me. And I'd like to explain why there's a cross out on my first slide. That's because when Norm asked me for a title for the talk, that was the first title I sent, Sharpening the Wedge Against Hunger with Organic Farming Practices. But the more I thought about it, there was a more appropriate title, and that's the one that I went with, and I'm going to explain either directly or indirectly why, and I'm also going to talk about what organic thinking is. So I think we all agree that it's important to reduce hunger, and it's really important to do it in a sustainable way. Feeding people at the expense of the environment is not sustainable, and there have been three, I think, significant problems in agriculture that we've always been dealing with, we continue to deal with: nitrate pollution of groundwater, surface water, soil erosion, and the way pesticides can impact the environment, farm workers, or even potentially our food. So here's where organic thinking starts. You don't have to read this, but the point of this is that this is from the USDA's National Organic Standards that are the law of the land here for organic growers. And there's this fundamental idea here that if you're going to control crop pests, weeds, or diseases, that I didn't, you know what? I don't have the clicker. Who's got the clicker? Oh, here it is. Okay. I've got the clicker. Look, the talk's going better already. There we go. I wondered why I had all those blank looks. Anyway, let's go right to here. These are the National Organic Standards, and what is important about this section about controlling pests is that the grower is directed to use many different practices, whether it's crop rotation or soil and crop, crop rotation or sanitation measures, cultural practices. I have to do two things at the same time here. Mechanical or cultural controls, augmentations of predators or parasites, controls like lures or traps, all these integrated practices that the grower should do to control pests before you finally get to this last paragraph here, where a grower can apply non-synthetic biological, botanical, or mineral inputs, which is the USDA's way of saying pesticides, to help control the crop, but only if these other practices didn't work. So I think that's actually an important and profound aspect of organic thinking when it comes to controlling pests, to help solve those problems of pesticide use and ultimately of pesticide use. So the organic thinking also extends to soil management practices, and the producer is directed to use practices that maintain and improve the physical, chemical, and biological condition of the soil and minimize erosion. So they can use different strategies to do that: crop rotations, cover crops, the application of compost. But the goal here is to do it in a way that doesn't contaminate soil or water from plant nutrients or organisms. And it's a great approach to farming where, yes, you're farming to fertilize your crops, yes, you're farming to improve the soil, but you don't want to contaminate the environment in the process. So all of this has been written on stone tablets. This is at the USDA facility in Beltsville, Maryland, and if you visit, you can see this there. So just a little overview of what we're trying to get at here. Organic farming is 1% of the cropland in the US, and the nutrients mainly come from animal wastes. Manure, blood meal, bone meal, feather meal, these are the wastes that are being applied to fertilize organic crops. No genetic engineering is allowed in organic farming. The other side of agriculture is the big side. 99% of US cropland is farmed conventionally. The nutrients are mainly from synthetic fertilizers, and genetic engineering has been widely adopted. This is kind of a symbiotic system here. There are roles for both of these kinds of farming. One, the nutrients from synthetic fertilizers are being used to grow feed, which are fed to conventionally grown cows and chickens and sheep and goats. But all the manure from those animals is what's being used to farm organic farms. So indirectly, the nutrient source from conventional farming is providing a lot of the nutrients from organic farming. The other thing is that if we want to impact the environment in a positive way, if we want to reduce soil erosion, if we want to reduce nitrate pollution, we want to reduce pesticides, it's the 99% where we're going to have the biggest impact on making those sorts of changes. The 1% is doing what it can using organic thinking, but we want to apply that organic thinking to the 99% in order to make the most significant improvements to the environment. So one of the important things in farming is nitrogen. It's really needed for crop growth, and it's going to be used no matter what, whether it's in organic form or a synthetic form. Nitrogen is going to be used, and since 99% of farmland is using synthetic nitrogen, it's going to be important for us to use organic thinking to figure out how to minimize that sort of use. Because right now, synthetic nitrogen is causing huge problems around the world, in the sense that plants are about the nitrogen use efficiency of plants is about 50%. So that means that potentially 50% of all nitrogen fertilizer that's applied can leach out of the field into groundwater, surface water. This is the mouth of the Mississippi River. Every year, a 6,500 square mile dead zone forms because the nitrates lead to algae blooms. The algae blooms die, the microbes take all the oxygen out of the water, and you get these huge dead zones. The thing is that these dead zones, it's not just the mouth of the Mississippi River. In the US, there are over 200 dead zones that form every year, as well as toxic blooms of algae that contaminate the drinking water of Lake Erie and some other inland lakes. And if you look at this view of the world in terms of nitrogen use, for many years I thought, oh, the U.S. is the biggest user of nitrogen in the world. But if you look at this slide, you realize that India and China are using more synthetic fertilizer than the U.S. or Europe or South America. And the problems of nitrate pollution there are clearly as significant as they are here, or even worse. And it's also interesting from this slide to see how the growth of fertilizer use has continued unabated right here, but also that the growth really has been in India and China, and Africa has had very, very modest growth in fertilizer use. Okay. So the organic thinking on reducing nitrogen runoff into ground and surface water is, number one, you can reduce synthetic nitrogen use. You can do it through precision ag, where you dial in exactly how much nitrogen you need. You could improve the nitrogen efficiency of plants. There's a company in Davis that's working on that. It's a genetic engineering project, but if it succeeds, it could have a huge impact on how nitrogen is used. There are some cultural controls. Researchers in Iowa have planted strips of perennial grasses on the downslope of corn and soybean fields in order to extract the nitrogen out of the ground before it gets into waterways. And this has proved very effective. You could use crop rotation. You could follow corn with like a small grain to take the nitrogen out of the soil so it doesn't leach out of the ground. And then you can also use organic sources of nitrogen, which are less soluble because they're tied up in their organic plant material, and they need microbes in order to break down, to be mineralized before they're available to plants. So if you integrate all these things together, you could have a farming system that loses less nitrogen to the environment. It's been shown that organic systems, in part because there's less nitrogen to leach out, have been shown to be 50 to 80% less prone to losing nitrogen. Another part of sustainability, if you're going to use organic nutrients, it's important to realize that if you don't use manure, if you don't use urban green waste, if you don't use feather meal, then they're waste products. And so it's important to be integrating them back into farming. For many years, I thought that this was the exclusive domain of organic farmers. But recently I was talking to a woman who owns a company that that spreads urban green waste compost on farms, and she said she had 60 clients, and I wondered how many of them were conventional farmers. She said 55 of them were conventional farmers. So I was really impressed that organic thinking was working its way into the local farm community. And these were growers that were interested in improving water penetration, reducing crusting. So it's important that this happens, and it seems like it is working its way into that other 99%. This is the student farm, by the way, where we make compost from manure. This is from the sheep barn, and that's one of our main nutrient sources. The third problem in agriculture is soil erosion, and this is Iowa. I'm not going to pick on Iowa, but soil erosion is a bad thing. Not only do you lose soil, but you lose the nutrients that were in the soil. And if there were pesticides in the soil, they get washed into groundwater and surface water as well. And then you also lose the water holding capacity of the soil, because whatever gets washed off was probably the most fertile and had the most ability to retain water. So it's not just Iowa, it's the whole world has been subjected to soil erosion, in part from farming practices, in part from grazing practices. But if we want to feed 10 billion people, we're going to need all the soil, all the viable cropland we can. And so our goal has to be building soil rather than losing soil. And somewhat promising trends, soil erosion in the US has declined, and I can't say it's declined to levels that are acceptable, but it certainly has declined. And a lot of, I would attribute this to better farming practices, conservation tillage, and no-till that has reduced soil erosion, especially across the Midwest. So the organic thinking about reducing soil erosion is building soil and using no-till, conservation tillage, adding organic matter in the form of compost, rotating crops, growing cover crops. There has been research that has shown that using cover crops and using compost does reduce soil erosion in farming operations. And there's a lot of research that shows that no-till is very effective in reducing soil erosion. Now, no-till these days is largely largely one of the practices that's done in conventional agriculture, because it's very difficult in organic systems to not till and then to control weeds. But there's actually a significant effort in California. Jeff Mitchell, who's a faculty member at Davis, is heading up a conservation tillage group that includes a lot of organic farmers that know that this is an important practice, that it is really organic thinking, and are trying to figure out ways of implementing it. This tractor can run tractor run, and this is the beginning of our efforts to do organic no-till. These beds were winter squash beds that we mowed, and then we came through with a sled that cuts through all the trash on top and chisels a furrow into the ground, and we can come in and transplant with our mechanical transplanter, or we could direct seed into those furrows. And if you're dubious whether it works, I can assure you that the crops that we have planted this fall have been doing fine. We had some beds that we did this no-till practice on, and some that we did till, and the crop growth on both is identical. But if we tilled this, we have a spader, which is this machine that's like having 6 people behind you shoveling as fast as they can, and it chops the heck out of the soil. Earthworms are damaged, soil structure's damaged, but it's very effective at controlling weeds. It's very effective at turning organic matter in, but this way, less soil erosion, more worms, and I think a more sustainable way of farming. So pesticides are used to reduce crop losses to insects and diseases, nematodes and weeds. And just this past week, I took my private applicator's certificate test, which allows me to spray pesticides in California. And I was reminded how every pesticide has caution, warning, and danger, depending on how toxic the pesticide is. And the test really emphasized how pesticides can impact the natural enemies of pest, how it can contaminate ground and surface water, how there were health hazards for applicators and farm workers, and how they should be used properly and only used when pests exceed an economic threshold, and how you should use the most selective pesticides and the least toxic. And here we go. So basically, the test reminded me of when I'm spraying a pesticide, whether it's an organic one or a conventional one, it's a hazardous material that has to be dealt with in a safe way. This is a slide of pesticide use in the U.S. from 2001 to 2012, and it tells a couple different stories. One story it tells is in terms of insecticides. The use of insecticides declined in the U.S., and I have to say that in the year 2000, there were 90 million pounds of insecticide used. That dropped to 73 million, dropped to 36 million. And this is the result of a number of things, but the most significant one, it's the impact of BT crops, BT corn, BT cotton. The important thing about this is that BT had a resistance management strategy which has maintained the effectiveness. So there hasn't been a rebound of insecticide sprays to control these same pests, because the material has largely remained effective over this 20-year period. If you look at herbicides use has increased over this period of time, and this also could be a reflection of the use of Roundup Roundup-ready crops, herbicide-tolerant crops, where in this case there have been a lot of benefits when it comes to herbicide-tolerant crops. As I said, it facilitates no-till, it reduces erosion, it sequesters carbon, helps store water, but there wasn't a built-in resistance, avoiding resistance to weed strategy. And so as a consequence, over time, there are 32 weed species that are resistant to glyphosate, and the growers sprayed more. So you have an increase over time of herbicide use. That's not really organic thinking. Organic thinking, you want to reduce the use of the herbicide over time. And that compares, as I said, to BT corn, where there has been a resistance management strategy. We got all these benefits from using BT corn, but in recent years, there's been a documented surge in resistance that indicates maybe even the resistance management strategy for BT corn needs to be addressed again. Perhaps a 5% refuge seed pool isn't large enough, or the corn has to be grown in a more integrated strategy. A number of techniques have been used. As an example, in cotton, there was a region-wide release of sterile males of the cotton bollworm, which greatly reduced the cotton bollworm population and essentially eliminated any buildup of resistance in the population. So organic thinking, integrated controls, natural enemies, where is it? Integrated controls, preservation, augmentation of natural enemies, use of crop rotation, crop diversity, resistance management strategies, and then pesticides as a last resort. So this is a field in the student farm where we're rotating crops, we have diversity, we have beneficial insect refuge areas, we have resistant varieties, and we use very few insecticides, almost never, although I have to admit that for sweet corn, I'd love to be growing BT sweet corn because that's a pest that's very hard to control with these integrated controls, and it would be nice to have that as a tool that would work. But I would never view that tool as a silver bullet, because in organic thinking, silver bullets are short-lived and not the way to go. So pests need to be managed with integrated controls. If you have a special control crop like BT or herbicide-tolerant crops, there really needs to be a resistance management a system set up. Otherwise, those traits are likely to be lost over time. Those crops are likely to be lost over time. And then nutrients need to be applied in a way that build soil, reduce soil erosion, and reduce nitrate leaching. So there's an example. Matt Liebman and his group of researchers were looking for an alternative to corn and soybean rotation in the Midwest. And they really used organic thinking. They took the strategy that organic growers in the Midwest used. They changed the rotation to corn, soybean, small grain, and alfalfa, and they added some compost. And with that, they were able to reduce synthetic nitrogen by 74%, herbicide use by 82%, clearly nitrates leaching out of the field were reduced, yields were as high. And this was way back in 2008, I've asked Matt a couple times since then, how many farmers have adopted this? And he invariably says, none. No one has adopted this. So the reality, hey, we're not on reality yet. The reality is that most agronomic decisions are driven by economics. But unless farming systems are improved, the environment is going to continue to degrade, and we just can't have that. So the use of cover crops and the compost for soil building really may need to be subsidized as carbon credit or conservation payments. We've seen that no-till builds soil, reduces soil erosion, so that's going to be an important part of maintaining our farming systems, even though a lot of it's not organic. Nitrate leaching, we may have to take a punitive approach and actually monitor nitrate leaching and soil erosion and penalize farmers for it, because it really is creating an unsustainable system. The biggest reductions in pesticide use have been through BT crops. The reduction rate was about 15 million pounds of insecticide each year. That's just a huge amount. So if that can be used in an integrated pest control system, it can have a long-term effective life. Organic farming, you're probably wondering about organic farming, is going to continue to be a limited part of the system, in part because it's driven by animal-based nutrients, and there just aren't as many nutrients available, as much animal waste available as you'd think. That's recoverable. Right now we're at about 1% of organic farmland. Based on the availability of nutrients, that maybe could go to 10% if a lot of effort was done, but that's going to be a slow process. And organic has limited access to modern technical advances, which means that growers, if they have the opportunity to grow crops that allow them to be sustainable but not organic, they may choose reducing pesticide use using BT. They might choose crops that have increased nitrogen use efficiency. And finally, organic farming may be limited, but organic thinking is not. And I think it can help make agriculture more sustainable by feeding the hungry. Thank you.